I'm Michael Maloney, founder of Satellite Design for Recovery.
I'm Robbie Boundy, founder of Space Impulse.
I'm Alistair Funge, Space Policy and Operations Engineer.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
So I am organized into 7 different mission areas, which are based on the kinds of capabilities that we're working on in each of those areas. So like communications is one of the mission areas. Position, navigation, and timing, or GPS is one of the mission areas. Space superiority, one of the mission areas. So in each of those mission areas, I have a mission lead, and the mission lead's responsibility is to be the public-facing entity for us in that mission area. What their job really is to do, go out and do this horizon scanning to learn what's out there, what commercial companies are doing, which ones are of interest to us and potentially useful, and then explain to those folks how they can partner with the government through small business innovative research proposals or grants or accelerators, or we have a number of different things, and we're really experimenting with lots of different new ways of engaging with non-traditional companies like the Space Pitch Day and things like that.
Welcome back to the Cold Star Project. I'm Jason Kanigan, your host, the founder of this thing, Cold Star Technologies, right now a data science and process improvement firm, but soon perhaps to be in the manufacturing field. I am here with Colonel Eric Felt. He just basically recently got into the Space Force, but he's been in the Air Force a long time. His title, and you may correct me on this, sir, Director at the Air Force, possibly the Space Force, Research Laboratory Space Vehicles Directorate. And I appreciate you being here.
Oh, thanks for having me today. You got the title right, and I'm happy to be here.
Awesome. Well, so I remember seeing a note from you or a post on LinkedIn saying that you were one of 49 Air Force Research Lab Phillips Research Site officers selected to join the United States Space Force. How has that affected your career? How excited are you about that? I know you're going to give me a party line, but maybe there's going to be a cool nugget in there.
Oh, I am so excited about it. I mean, who would have thought back in 1996 when I came on active duty that I would one day be joining the Space Force. So Air Force has been just a wonderful career for me, filled with lots of great experiences and surprises and opportunities to do good things. But now, it's another opportunity to go into this newest service that we haven't stood up since 1947, and just kind of a clean sheet to go off and do awesome things in the space domain. I think it's an incredibly exciting opportunity, and that was honestly one of the most exciting little events that I've been able to be a part of there in October, when I could tell those 49 folks that, hey, guess what? You applied and you were selected, and we're going to go join the Space Force. Pretty neat stuff.
Yeah, incredible. I love something new and getting to mold some values and choose some direction and things like that. So the number one reason that I wanted you on, but the funny thing was you and I were connected on LinkedIn before this, is the State of the Space Industry 2020 report, because you were one of 4 top line signatories on there. And so I wanted to hear from your point of view what the biggest takeaways were from both the process of producing that report and also the concluding product.
Yeah, that was a really good experience. That was the first virtual conference that I was a part of since COVID broke out, and it was really surprisingly effective. It's always good to be face to face, but one of the advantages of this format was we got to have real thinkers from a lot of different government agencies that might not have otherwise been able to attend the conference could be a part of it, and so we had some really good discussions. I would summarize it as the state of the space industrial base is strong, but fragile in that U.S. leadership is not at all guaranteed, and we really need to be aware of where we are and take proactive steps to make sure that we can stay ahead in this area, which is so important to our nation and our DoD.
Excellent. Yeah, and I did a thing with Dr. Gordon Ressler when it came out, who helped out with that. He was very clear to jump up and down and say, I didn't do the whole thing. Well, we know that, but and I didn't even know that he had anything to do with it when I asked him to comment. But I have shared that since and said, look, if you want to understand what the DoD is doing and what these folks want, read this report. Yeah, it's 80 pages or something like that, but really dig into it and align yourself with what they're saying in here, because this is part of the voice of what you want, right? So how would you recommend space industry folks, civilians included, make use of the report?
Well, there are some direct recommendations for industry in there, as well as the direct recommendations for government. But really, the most eye-opening thing to me that came out of that whole experience was the humbling realization that the DoD is not driving this second space age. You know, we did drive with NASA the first space age and the race to the moon and all that government investment, and that was great. But this one is being driven by commercial interests, and they're really going at a much faster pace because of that. And we just need to realize that, you know, we're not in the driver's seat on this. We need to get in the partnerships with the folks that are. And so really a realization that, you know, we need to be closer to the commercial industry, and we really need to use all the tools of government. I was thinking, you know, before that conference, I was kind of thinking about my own research projects, my own organization, my own contracts, and I really came away realizing, you know, we have a whole bunch of other tools in the government that we can use to make this more of a whole of nation approach. You know, things like the space commodities exchange and finance and education and things that you know, were kind of not on my radar screen before. I really came to the understanding that all these things can and should work together, and that when they do, that's a really powerful model. So if industry can come away with that same kind of understanding, I think that's the most important thing to come out of it. And then we just need to look for the next level of details of, okay, well, how do we do that? You know, we all love education, and we want to produce more engineers. Well, how, you know, what are the steps that we get there? Or we all want public-private partnerships. You know, what are the mechanics of how we can make that happen and keep you know, U.S. industry ahead in this area, because that's good for the whole nation and for the government too. And for the community.
Right. Well, I'm delighted to hear you say that, Colonel, about this shift, and it's no longer, all right, folks, line up in front of the desk and we will see you now, sort of thing. It's quite a shift.
We can't do that anymore. That model just isn't going to work anymore.
Excellent. Well, I look forward to seeing some more of these details come out too, about how to partner up on that. I know there was Air Force Pitch Day and a couple other things, but it looks like we're going to be broadening that out. So let's hear about the Space Vehicles Directorate. It's relatively new to me. I'd like to hear what its purpose is and what your job is like, you know, running the thing.
Well, so our mission is to, I like to say it, to keep the big idea pipeline full. So when the Space Force needs new technology, I want to have, you know, thought of that need 5 or 10 years ahead of time, and explored 100 different ideas. And among those 100 different ideas, you know, found 10 ones that are worth further maturing, and then have those ideas mature when the Space Force needs them at the end. So that's the big idea pipeline, and just a way to make sure through that whole thing, we're finding the best ideas from horizon scanning up front, exploring the military utility of them, looking at what's going on in the commercial space and how to best partner and shape with the development of those ideas, and then so they come out of the pipeline at the end, just right when we need them, even if the Space Force didn't know they were going to need them. So that's kind of my vision, is we got to keep that pipeline full. And by full, I mean we've got to keep it full enough that we can continue to stay ahead of our competitors in this space, because there are very smart and active companies and businesses and governments that don't necessarily are not aligned with our interests in space and in the world, and technology is one of our key advantages, and we have got to keep it that way. The thought of a world where that's not the case in space would not be good. So that's really my mission, and that's what I try to do. It's like super exciting, because you're always getting to look at this new technology and think of new uses for technology. And, you know, we just this year announced 2 new research programs after a very thorough process of vetting ideas. And from 27 ideas, we got down to 2 that we selected. And, you know, one was at very low Earth orbit, where you have to be constantly thrusting just to even stay in space and not re-enter. And there's neat things you can do at those orbits. And then the other one is way out at the moon with the CisLunar Highway Patrol System, which is so important that we understand how to be able to operate out at the moon when there are, you know, threats and things we need to be worried about out there. Those are some of the funnest parts of this job.
Okay. Tell me, let's get blunt. How would you differentiate yourself from NASA, NIAC, or DARPA, who are doing sort of similar things? They're also looking out into the future and trying to fund ideas. I can think of one lens, obviously, that you apply that they don't. but tell us about that.
Well, our focus, our number one goal, which comes from the Space Force, is the resilience of our space capabilities. And so that's a little bit of a different focus than NASA's space exploration mission, or than DARPA, which is looking for real moonshot technologies. I like those, but I also like some of the stuff we do is not is a little more routine and evolutionary than that, but that's okay if it's focused on the real important parts of our architecture. And by resiliency, what I mean is we have to make sure that our nation's space capabilities are there when the warfighter needs them the most. So if you are in a high-end conflict with China or another adversary like that, and your SATCOM goes out, your GPS goes out, your space capabilities that you're counting on are not there when you need them, that's a huge problem. So by resilience, we are very focused on what are the technologies we can develop to make our space capabilities be there when the warfighter needs them the most. So that's my focus, which is kind of unique among those other agencies. And the other thing that I think makes us unique is that I'm focused on a timeline that's probably 5 to 15 years out in terms of operational capability. There are a whole bunch of agencies that are solving urgent needs. Right now, this year, I'm going to deliver this thing, and that's important too. But we're really the only ones, at least in the Air Force or the Space Force, that are focused on that timeline where we have some time to do development, but we're also not going to be 40 years in the future with the kind of technologies that we are able to deliver. And we do some of the technology development ourselves. That's kind of one of our another part of our secret sauce, where we actually have engineers here that can build satellites, which is different from some of the other government research entities. So with those kind of, we do have a little unique part of the pie there that has made for some great inventions and breakthroughs over the past decades from the Space Vehicles Directorate.
Okay. All right. And it's different from the SDA as well, which is probably maybe a little more long-term thinking, or?
The Space Development Agency is they're fielding operational capabilities. So they have really, what they've noticed is that there's all this commercial activity and all this capability in proliferated low Earth orbit constellations. And that is true. Look at what SpaceX is building, and all of those small satellites that can now act like big satellites are very potentially useful to the Air Force and the Space Force and the DoD. And so they saw that, and they've gone after developing that into operational capabilities. But they're not really in the research and development, science and technology business. They are building currently available capabilities and into currently available technology into operational capabilities. So that we're not really doing what they're doing either, but they are one of our customers. They have been very receptive to taking our technologies that we develop and operationalizing them. And so I love them for that.
Right. Okay. Well, that clarifies that very well. I've been studying electronic warfare myself, just coming out of the spectrum, and then discovering that it made sense to me in that. So when you're talking about this communication and having those systems available and be resilient, that speaks to me because I realize kind of just how easily some of these things can get knocked out, right? Okay. So when should someone out there in the world be thinking about approaching the Space Vehicles Directorate, and how would they go about it?
So I am organized into 7 different mission areas, which are based on the kinds of capabilities that we're working on in each of those areas. So like communications is one of the mission areas, position, navigation, and timing, or GPS is one of the mission areas, and space superiority, one of the mission areas. So in each of those mission areas, I have a mission lead, and the mission lead's responsibility is to be, the public facing entity for us in that mission area. They are available to contact, and I could certainly provide you with a list. What their job really is to go out and do this horizon scanning to learn what's out there, what commercial companies are doing, which ones are of interest to us and potentially useful, and then explain to those folks how they can partner with the government through small business innovative research proposals or grants or accelerators, or we have a number of different things, and we're really experimenting with lots of different new ways of engaging with non-traditional companies like the Space Pitch Day and things like that recently too. So we're really that's what my mission leads do, And that's how we've tried to reach out through those formats.
Okay, excellent. So that again clarifies that. All right, well, let's hop over to space domain awareness. And I know you folks want to talk about this, and so do I. In CisLunar space, which we're also calling XGEO, I would like to hear about your plans for space domain awareness.
Oh, definitely. Well, it's a very exciting topic because it's hard, and we like hard problems. All right, and yet it's something that's important. So working on an important problem that is also technically challenging, we love that kind of stuff. And so, well, when we first became, realized that that the geo belt is no longer as high as we need to care about, because there are interesting things that we are going to need to do above the geo belt, and we've got all kinds of activity from other nations and commercial activity on the moon and around the moon and in other orbits above the geo belt. So we need to know what's going on up there. Now, we have had, I by no means mean to say that we have solved the space domain awareness problem at LEO, MEO, and GEO. We have not. It's challenging there too for different reasons. But above GEO, some of the challenges we face are that, first of all, the volume that you have to search is 1,000 times greater, because the moon is 10 times as far as the geo belt. So if you've got a 4 pi steradian sphere, the size of the moon, that's 1,000 times bigger than what we are thinking about today. So that's just an immense amount of volume that needs to be searched. It's further complicated by the fact that the moon is so bright. And you can't see through the moon. So we like to joke that the moon is bright and opaque, and so that is a problem. And so the reason that's a problem is that if you have we do a lot of our space domain awareness with telescopes on the ground, and they work great. You can see light reflected off telescopes, track them. That's the foundation of what we do for space domain awareness, especially above LEO, where radar is pretty effective at LEO. But above GEO, when you are trying to search for stuff near the moon, you really can't see it because the moon is so bright. It's the lunar exclusion zone. We call it the cone of shame, really, because it's a cone from the Earth going out to the moon, and that's a real challenge for doing it from the Earth. So we quickly realized, you know what, you're going to have a satellite up there in space to help you with this space domain awareness, because some of the worst threats and the most interesting activity is happening near the moon. So you need to know what's going on near the moon. And so you're going to have some kind of space-based asset out there to perform your space domain awareness. So our thought was, okay, let's put a small satellite up there and let's put a camera on it, and let's navigate around the moon and see what the best ConOps and how should you go about doing this space domain awareness in the cone of shame, which is going to be the hardest part of it. And that's what the CHIPS program is all about. Of course, it's a reference to the COP show from the 70s, which we loved. And then it's also the highway patrol system that's going to go out and tackle the lunar environment and what we need to do up there. So that's just our first of foray into how do we operate up there. The third complexity is that that orbital determination is by no means a simple thing when you've got the gravity of the moon to worry about too. When you're close to the Earth, you don't have to worry about the gravity of the sun or the moon, really. When you're up near the moon, you do need to worry about that, and it makes for some very strange drunken sailor type orbits, as we like to think of them, that it makes it extra challenging, because if you don't know where a certain satellite is and where it's going, then it's even harder to maintain custody of it and awareness of what it's doing. So those are some of the technical challenges that we're trying to get after, so that when the Space Force needs to do operations up there, which they will, we use the maritime analogy where the Navy has to protect the sea lines of commerce. And when there are space lines of commerce, the Space Force will have the mission of protecting them. And they will need to conduct operations up there and be aware of what's going on for piracy and other threats that could be involved. So before they need to do that, I need to develop the technologies that are going to enable that and make that possible. And that's what I'm working on in that CHIPS program and in that mission area.
Okay, well, the good news is, Colonel, that when the CHIPS program came out and people were talking about it, they got it. they got the reference, so it wasn't wasted.
It wasn't meant to be subtle.
Right. Hey, this is Jason Kanigan, the host of the show and the founder of Cold Star Technologies. I want to share with you a new idea. This is very exciting. It's a partnership between myself and another fellow who's a former Marine, a space junkie, a guy who has a lot of experience with like Ogilvy and marketing, and he's also a junior venture capitalist. And some of you may know that I've been a copywriter myself for 25 years and made a lot of money for myself and clients. And so we are partnering up along with a legal team and junior associates. It's very exciting to be able to do something. Here's the exciting part for you, okay? If you're a founder and you're interested in like, hey, where's the venture capital? We see this a lot, right? You need a bunch of stuff to be able to qualify for venture capital, including like customers. And in order to get there, you need stuff like branding and teams and like a business model and all this stuff. And I find a lot of founders, and you ask yourself this question to tell me the truth, right? Tell yourself the truth. You don't even have to tell anybody else. Do you understand all those things that we just talked about? Or do you just want to build cool stuff? And that is the position where we find a lot of people are in. But look, this project Space Boots that we're looking at here, here's our mission, okay? We're what's called a venture builder. We're seeking to provide venture capital, marketing strategy, and networking for brands, companies, their teams, individuals. Here's the niche, okay? If you're seeking to add value to the 7 space power disciplines as defined by the Chief of Space Operations for the United States Space Force, we want to talk to you. And if you don't know what that is, go to Space Capstone Publications and get the PDF for free. You could buy the hardcover book if you love flipping through catalogs like I do, but the PDF will do, okay? So here's who we're looking for. Pre-seed and seed stage startup companies looking to enter these 7 disciplines, one of them. And we are going to provide the help at this pivotal stage. Most importantly, the storytelling, pitching the big idea. That's what you need help with here, is that positioning, the branding, the storytelling, and that will get you the access. That will get you the stuff you need to get access to that venture capital. We are going to help you craft a winning narrative on this increasingly complex road to funding. We're very excited about this, being able to offer this. It's something that I'd sort of daydreamed about over the last 6 months or so, and suddenly found a partner to be able to fulfill the idea with. If you are in that realm, if you understand what I'm saying and the potential that this is bringing to the table, come talk to us. You can just email me or connect with me on LinkedIn and message me there. Because if you're in one of those disciplines, you should be talking to us about the Space Boots project, the world's first space tech venture builder for the Allied Space Forces. Super excited. Let's get back to the interview. Have you considered using transponders on satellites like airplanes do, or is it best to just leave it?
That's a fantastic idea.
Okay.
So, and the technology is there. It's been demonstrated. It's like the airplanes that can report to each other when they're in the neighborhood. And we really need to get to doing that as space becomes more congested, especially in the LEO domain, where you got 1,000 satellites launched just in the past year into LEO, and so we need transponders and other technology like that. Really, what we need is some standards to be imposed that all the different operators are going to, just like in the air domain, put this transponder on there, deorbit your satellites in 15 years or whatever the right number is, self-report your position. I mean, there are ideas out there of what we need to do, but it's kind of a policy and a political thing to pull together those standards and norms of behavior. And in fact, I think that's an opportunity for industry too, is that, as much as the government would like to, rather than waiting for the government to, impose these things by law, if there are, IEEE standards or, space standards or from an industry group that could be imposed, I think that would be helpful. Debris is a potentially serious problem. As you get more and more satellites up there, the chances of collision, of course, are going to go up. It's inevitable that we're going to have some more collisions, and that could pose a threat to everybody's space capabilities. So I think there is a need for that kind of activity, and what I'm trying to do is work on any technology enablers to that, so that when the industry groups or the government groups decide that they want to go down these roads, they'll have the needed technologies available.
Okay. It can be hard to get agreement, folks, from
absolutely. Well, that's why we don't have any an agreement yet.
It can be hard to do, but I do believe people are just going to start using something, and that'll probably end up being a de facto standard sooner or later. So
agree
very,
with you.
very cool. Very cool. Well, my next question here comes, I asked Dr. Morabajah what he thought. I should ask you about. I like to go to the experts, and he brought up the idea of satellite autonomy. Folks, what that is the satellite figuring out some decisions for itself to be able to avoid collisions or go somewhere like that. Do you have any plans to work on satellite autonomy, or are there any current ones under your administration that you can talk about?
It's already a big research area, and it's an important research area. I mean, first of all, you got the number of satellites going up exponentially. There's no way you can not use autonomy. They need to be able to do some simple things themselves, like cruise control on a car. The distances that we're talking about are further. You know, if you talk as you get above GEO and out towards the moon, you need the satellites to be able to make more decisions on their own, because the comm pipes are not as robust in terms of, you know, all the data that you can send down to the ground and how quickly you can command the satellite. So as the distances go up, you need autonomy. And then just you need to, if space is a warfighting domain, you need your satellite to be able to make decisions faster than whatever your adversary and enemy satellite is doing up there. So, I mean, it's just, you have to have autonomy. And we have done a number of experiments over the years in progressing autonomous capabilities. The latest one was our Eagle and Mycroft experiments, where we were doing, you know, rendezvous and proximity operations with Mycroft automatically navigating itself around the Eagle satellite. That's super important technology. And we've got more stuff coming. Chips will have to have a high degree of autonomy on it. So I think every experiment that we launch will do additional experiments in the autonomy area. There's it's not just technical barriers. I mean, we do need more powerful microprocessors, and, you know, you got to have the right kind of sensors up there so that they can make the right decisions. But, you know, there are policy hurdles too that have to be thought through, because the consequences of autonomy or AI run amok in space could be bad. So, you know, it isn't just a matter of building the autonomous system. You need to show that your autonomous system is safe under a wide variety of conditions, so that you don't do harm to the other capabilities that are up there. So I think it's a super important and interesting research area. Yes.
Okay, well, I loved hearing about it. Drove home the electronic warfare thing again, where you do want to move faster than your opponent, and there's this sort of cat and mouse game going on.
You have to. Yep.
Yeah. I'm constantly sending people to Celestrak. Folks, if you have not been to celestrak.com and fired up the visualizer there and had a look at just how many satellites there are in orbit, low Earth orbit, let it populate, and then spin your mouse wheel a little bit and back out to GEO, and you'll see that there are even more. And that should scare you a little bit, because there are a ton of them, and we are throwing up more and more and more up there, and something needs to be done. Which is what we're talking about.
Totally agree.
Very, very exciting. Well, let's finish up with this, Colonel. You just broke ground on a new Deployable Structures Lab. Tell us about that. It's $4 million, 7,000 square foot laboratory, and it continues the work of something called the Spacecraft Component Technology Center of Excellence. I'm a board member of the Operational Excellence Society, so I love that word. Tell us about what's going on there, and let's hear some details.
Sure. Well, our overall strategy with space technology is really to make small satellites perform like big satellites. And by doing that, you can kind of get the best of both worlds, where it's easy to build small satellites. You can do it faster. You can launch them cheaper. And yet, when they get on orbit, if they can act and perform like a large satellite, then you're really able to get a lot more of your mission accomplished. So one of the ways that we do that is with deployable structures. You know, it can be all folded up when you launch it. And then when you get up on orbit, you can roll out your solar array, you can roll out your antennas, you can, the deployable structures is a key enabler to that vision of making the small sats act like big sats. So this is just a test lab where we're going to be able to test larger structures than we've been able to test before, so that when they get up on orbit, then we are sure that they're going to be able to work. Some missions just can't be done without deployable structures, and one of those is the solar power beaming mission, which is not a new idea at all. Been around for decades, but newly technologically feasible. is how we look at it. And the idea is that with Spider, as we call it, is that you'll be able to have solar energy coming in on one side, and it'll be directly converted into RF energy, and then you can beam that RF energy anywhere you need it. So to the ground, to another satellite, perhaps to a UAV or a moving vehicle. It's just gonna, power on demand is gonna be a huge enabler to our forces of the future. So there's great potential mission capability there. The technology is possible, but to get operationally useful amounts of power, we're going to need perhaps 10,000 square meters of these cells on orbit. So you are not going to be able to launch that all by itself. You're going to have deployable structures that that launch all folded up and then unfold. You're going to even have to have on-orbit assembly as you link these things together. So there's some interesting technical challenges to getting towards that power beaming vision that we think would be so useful. And so this facility is just one way that we'll be able to test some of these deployable structures on Spider and the other programs that are important to us. We have a satellite up there right now, Demonstrations and Science Experiment, DSX, that is the largest unmanned structure in space. 80 meters tip to tip, because it has to be. That's the length of the antenna to broadcast the very low frequency waves to do the ionospheric research that we're doing, but it didn't launch that way. It launched all folded up, and then when it got up there, the antennas deployed very successfully, and that's just one example of the kind of research that we'll be able to do in that facility. And not just AFRL, but the whole idea is to provide a government facility that small businesses can come in and use. Large businesses, if they don't have one of their own, can come in and use. It's really, I view it as a shared facility that through research agreements, we can work with others to have that as a common test capability for our space capabilities.
Okay, I love it. I'm hearing the deployable structures, robots and space guys will be very happy about this on-orbit assembly. And we're talking about high-strain composites as well as the material to be using this. And I think of Rob Hoyt and his company as developing something similar. Is there a great loss of like energy in the efficiency as the energy is collected and then transferred and then transmitted and received, or is that a relatively simple procedure?
On the power beaming with Spider? Yes, there's lots of efficiency losses, but that really isn't the figure of merit. That isn't where you get the military value. You get it from having power on demand. So if there's some other way that you can get power by plugging into the wall or having a diesel generator, that's always going to be better. But when you really need power and you really need it at a certain place, you need it right now, that's super valuable to the warfighter. And then over time, even if the efficiencies will come up over time, and eventually it may be a cost-effective way to power cities, etc. But at first, the real military value will come from just delivering that power on demand when you need it. I mean, think about not having to drive a big truck of diesel fuel over the roads of Iraq or Afghanistan or something. I mean, it would be very, very useful to not have that, to reduce that logistics trail in a dangerous environment like that. So efficiency is not, we're going to start with low efficiency, and I'm fine with that.
Yeah, my engineering focused mind is blurting out all sorts of questions, but I'm not going to ask them because we probably want like range and times and things like that. But I want you to know I'm thinking about them. And that's
good. Those are great questions.
Very cool. Yeah, exciting questions here. Okay. Well, let's finish up with this question then. So high strain composites is not a phrase that most people have heard in their lives. So let's define that and just say very simply why that's so useful.
Well, every pound that you put into space determines the cost of your launch, and the cost of launch has certainly gone down at least by a factor of 4, thanks to SpaceX and competition in the launch market. But it's still expensive to put mass on orbit. So composites in general are a great idea because they are very low weight relative to the strength of the materials. And the high strain composites are important to us because a lot of the structures that we're want to put out in space are very large, and there's going to be a lot of forces involved when you move or rotate that structure. And so you need your composites to be very strong in the ways that are going to stay in good behavior as the satellite moves. So that's all it means. It just means that you're going to use surfboard materials,
Right.
composites in space, and because they provide you a lot of advantages to having your structure be large while still lightweight. And so my mind is just taking the advantages of a lot of the innovations that have happened on the ground through these composite materials and putting those up into space and seeing what we can do with them.
Excellent, excellent. Well, I really appreciate this, Colonel Felt. My guest has been Colonel Eric Felt, formerly of USAF, now in Space Force, the director at the Air Force Research Laboratory Space Vehicles Directorate. Thanks a lot for doing this.
Thank you, Jason. It's great to be here today.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Star Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks